Hi, thank you everyone. My training is as a mathematician, and this is my first foray into math education research. So I'm hoping the questions at the end will be suggestions about how to be a better education researcher. Okay, so as a result, I'm gonna organize my talk like it's a paper with an introduction, motivation, background, question, method. I'll describe the course, the students, the data collection, results. I have some relative and absolute results and a little analysis. And then some discussion of the validity and any little indications of causes for the results. So motivation. At these kinds of conferences and in Primus, there are claims made about IBL. There's one paper in Primus entitled "More is Better," which is excellent. And people often claim, in fact, the first talk in this session talked about higher and lower order tasks. And so I wanted to investigate for myself. Are students really doing higher order things in my IBL class? I would like to move from sort of a reflective teacher to an evidence-based researcher on education. The work of Sandra Larson and her colleagues that she presented about last year, and you should all read if you haven't, does a great job of showing us that the classes that are designated as IBL are very different inside the classroom, but that's clearly not the whole IBL experience, so I wanted to see if there's anything else there. More of the whole experience, and a theme that has come up several times, I'm interested in how the students perceive it. I'm the only IBL practitioner, or I'm the major IBL practitioner at my institution, so I'd like to have a little bit better sense of what they think about. So background, I'm going to use higher and lower order in the sense of Bloom's taxonomy, and there's a lot of stuff here that there's a debate about the last two that I'm not really going to get into. But the first three are remembering, understanding, and applying, sort of things that don't involve as much creativity, and then analyzing, evaluating, and creating the things that do require higher order tasks. So that's what I mean by these terms. Okay, so my question is, how does the proportion of time spent for my IBL class on higher order Bloom's tasks compare to the proportions in my students' other classes from their perspective? And if there are any differences, does any of the other data I have taken indicate why this might be happening? So I don't know if Annie Selden is here, but she always asks, tell me about who the students are. So this is what it is. It's a modern geometry course. It's a 300-level course. It's proof-based. It has linear algebra as a prereq, which is a proof-based course, which has a prereq of our introduction to proof discrete. So this is at least their third proof-based class. For most of them, it's their fifth proof-based class, and their last math class. It's required for secondary math education. It is an option for the rest of the department. When I teach it, my goals are sort of in two parts, that they internalize the axiomatic method and values that professional mathematicians have about the nature of mathematical truth, so metamathematical, and that I add coherence to their geometry content knowledge. Number of students, 10 2 years ago, 9, 7. This year, so 7 is bold because that's the group of students I took data on. This year they happen to be all juniors, and they all happen to also have an IBL Introduction to Proof course with me last year. So it's a very uniform group of students. So my solution to making this course a valuable experience, which I've talked about in other settings before, is that the course is structured as the students writing a textbook, and that textbook is formatted as a wiki. We used David Clark's excellent book that you just heard about, which is fantastic. Nobody said that word at that panel, but it is. So before class, the students prepare solutions. In class, they discuss in groups and present. After class, they publish that material to the wiki. Eventually, they're expected to revise the existing material. And then they do some, I hesitate to use the word, higher order things, summaries, and sort of forward and conclusion, some synthetic material to the topic. So that's sort of what I mean by IBL here. Weeks 1 and 2 is that. Week 3, they prepared for and presented at a workshop for in-service teachers. 4 through 7 was again back to traditional IBL. And then for the last 3 weeks of the term, we read a biography of Kurt Gödel, which provided a lot of help on the sort of meta-mathematical goals. And then they continued to work on the revisions. So how did I take my data? At the end of weeks 2, 4, 7, 10, and the course, I gave them a questionnaire where I asked them about how much time they spent per week, I gave them a little refresher on Bloom's taxonomy, so make sure we were using the words the same way. And then I asked them about the absolute percentage of time at each level. So what percentage of the time spent on this class during weeks 3 and 4 was spent remembering? And then relative. I spent a smaller, similar, greater percentage of my time remembering in modern geometry as compared to the work time for my other courses during these pair of weeks. So some results. Blue is smaller, red is similar, and green is greater. The students, so I just added up the number of votes for each of those for the 3 higher order tasks. And quite clearly, the students believe that they spend a greater percentage of their time on my class doing the 3 higher order tasks. And you compare it to the lower order tasks, which is red with some blue in it. So much greater in one and similar in the other, which doesn't work out. Right? We'll talk about that. But the profiles for these 6 are not the same. The three lower are not the same. So no, this is the number of, so there are 7 students. There are 3 things at that level. There are 3 lower level for weeks 1 and 2. So there could be 21 votes for things. And this is how the 21 votes are distributed. Sorry, not percentages. That's number of student responses. You can also see how there's agreement here and much less agreement here. So remembering is mostly blue. The winning, and this is time, by the way. This is the time axis. Mostly blue, mostly less with 1 week that was similar. When you move to understanding, the sense I get is red with a mixture of blue and green. And then if you move to applying, it's red with a mixture of green. So the 3 lower level this is why there's not much agreement, because the 3 lower levels are different from each other, and it appears to be sort of a trajectory. The 3 higher levels are all pretty similar. They're all just sort of green. I picked evaluation here because there's a big change between week 7 and week 10, and that's on purpose. At the end of week 7, we finished with IBL, and then for the next 3 weeks, they spent all their time evaluating the existing content. So it does appear to be sensitive to what's actually happening in the class, which is great. And then if you'd like to see one moment in time, but all 6 of them, you get this, which tells exactly the same story. Remembering is blue, understanding and applying are red, and analyzing, evaluating, and creating are green with a hint of red. So again, this is the sort of relative data. It all indicates that, in fact, they do spend greater percentage of their time doing higher order tasks in this particular class. Now we move to I also asked them what percentage of their time they spent doing in each one. This image is a little bit messy. So we'll just pick out one of them. Let's look at creating. You see how they spend between 20 and 17% of their time during the course, but overall about 24% of their time. Now, there were a couple of days intervening, and there were a couple of really high-powered creating tasks that happened between week 10 and the final one. So it's possible that that's what this is measuring, but it doesn't always make a whole bunch of sense. You can see for the last 3 weeks and the course, the 3 higher order tasks are above the 3 lower order tasks. So just to simplify this, I'll combine the lower and higher level tasks. This astounds me because the blue is the lower order tasks. So every single week, on average, the students believe they spend more time doing higher order tasks than lower order tasks. And Bloom's taxonomy is also often presented as a triangle, like the food pyramid, and the food pyramid is upside down here. And again, it's sensitive to weeks 5, 6, and 7, moving to 8, 9, and 10, when it really did become very much about evaluation and synthesis. And also you start to see a downward trajectory here. I think that represents them getting more comfortable with what's going on. And okay, I've already got axioms for that. I really am just applying. I am doing lower order tasks now that it's easier. So this is the shape I would have guessed if I could put it somewhere, which is awesome. Again, the individual items are a little bit messy. You see in this portion of the graph, it's sort of all over the place they don't agree with each other. This is a 35% band. That's pretty huge, right? That's a third of the possible range. So most of them look like this, sort of messy. This phenomenon here, I think, corresponds to them saying, oh my God, you're asking so much more of me than my other classes at the beginning. And also them not believing me that I meant percentage of their time on the class as opposed to percentage of their time. If they spend more time on my class, of course the percentage in the class seems, I think they were answering the wrong question in the first week. But evaluation is the only one where there's a really coherent move, and again, between week 7 and week 10, everybody goes up. And that's where I really think the evaluation portion of their work turned on, and you can see that. You can see that in the data, which is exciting. So, some questions about validity. There's an extremely small number of students, right? That's why there's nothing statistical going on here, because that would be silly. And there are 2 tracks. 5 of my students are secondary ed, and the other 2 are not. They appear to have different, I mean, there's only 2 of them, so it's a little, and one of them was the flaky one who didn't answer all of the surveys. But they appear to have a slightly different response structure. As we talked about, they may be thinking about more than 100% of their time. I also asked them how much time they spent, and on average, they said they spent about 5.5 hours a week on their other classes and about 11 hours a week on my class, which, you know, there might be some inflation there, but 11 is right in the range that they're supposed to be spending, so I'm okay with this. And it was different per student, and it was different per week. It did, in fact, change. They may be telling me what they think I want to hear. I'm not sure. On the plus side, I mentioned a Bloom's refresher question on the survey. It was a matching question where I gave 6 calculus tasks, 1 at each Bloom's level, and asked them to match them. It was the same question each time, but it was the definitions, and then the matching question was to remind them what these terms meant. I avoided using these 6 terms in class and when discussing with them. I used the word like synthesize, but I tried to avoid using the word create so that I didn't bias them. 5 of these students have taken an educational psychology course before, so they were familiar with Bloom's taxonomy, and they seem to have a relatively stable understanding of what the terms meant. And then on 2 different occasions, I asked them, what activity would you put at this Bloom's level? How much time do I have? Okay, so we have enough time. In short, the descriptions that they gave match perfectly with what I would have said. So I have a couple of example quotes. Remembering, when proving theorems, being able to recall and state specific theorems, corollaries, axioms used to solve. Just sort of a declarative thing that you needed to have. I like the understanding one. When I finish a proof or someone shows us how to do a proof, I have to make sure I understand the methods used completely because they're almost always reused in future proof. So it doesn't say reuse them, that would be applying. This just says sort of translate it into their own understanding, which is exactly there. Evaluating, we've talked a lot about. We keep progressing and deciding whether proofs are justified or if we are doing all that is necessary to be perfect. They are deciding whether or not something is good enough, which is exactly evaluation. So these match perfectly with what I would have put. My only concern is that every time I asked, I essentially got 1 response per thing. I think if I want to get more nuanced data about how they perceive these levels to be happening, I need to do it in an interview form where I can follow up and I can keep saying, well, where are there anything else? I did for the final one, give them a list of all the brainstorm tasks from the class that I could think of. And some of them did seem to refer to that, to jog ideas about where they might be doing these different levels. But I'd have to push that a little bit further. The other piece of corroborating, evidence, I'm interested in causes as well. So I always ask this pair of questions at the end of an IBL class on the end of term evaluations. In what way is the role of the student different in this class from your other classes, if any? And how do those differences, if any, affect you as a learner? I love these questions, and I get really interesting responses from them. And here are 4 of them that I'd like to share with you. Some of the bolded words are themes that I think are related to causes and themes that come up regularly. So not only do I have to take responsibility for my work and contribution for the course, but I also encouraged, evaluated, and responded to other students' responsibility to put forth effort too. The difference has made me more aware of how to always be prepared and confident with the work and effort I put forth. When my contributions and effort affected those around me, I made more effort to try harder, reflect more, and contribute as much as I could to benefit myself and my peers. Responsibility is hands down the word that I get the most over the years, and here too. But there's a sense of sort of in it together here. This particular cohort of 5 education students has almost all of their classes together. They do all their, I expected this from them. I often get this aware. They see a new level of what it could mean to be prepared for something. the reflect, that's a new and exciting one. There was a lot more reflection in this course than any course I'd ever taught before, so it was nice that it appeared. Well, this one I highlighted questioning my own work, so there was more evaluation work here. That's what the student thought. Okay, this third one. Even in the other proof-based classes I have taken, it still very much felt like I was being dragged along 80 to 90% of the time. In this class, through the virtue of the pre-work, we get to at least attempt every proof in the book. Even if we didn't figure it out then, it was always one of us that got it eventually. We were never given anything on faith. We get to build everything ourselves. It was a pleasant transition from being taught to learning, which is an excellent quote that I love to share with you. And this is a particularly reflective student. He's very articulate about what's going on. But again, the sense of taking on the role of authority and that they're responsible for it. Yeah, and I think, so in my own way, that was also personalized, which was useful for some of these students. So I believe that is the end. And again, I'm particularly interested if you have any suggestions on how I could better write this up. Thank you.